Presentation belongs to Miss Tuğçe Sezgin. Tuğçe Sezgin from İzmir Institute of Technology, and we connect online to her. Can you hear us? Continuously.
Hello.
But we can't hear you right now.
Can you hear me?
No, we can't hear you right now.
Sorry. Can you hear me now?
Can you please increase your voice volume?
I'm trying, but... Is it okay right now?
Please. We need more.
I'm sorry.
Can you please talk a little bit?
Okay. Now
Okay.
it's okay?
Yeah, okay, we can hear you right now.
Okay. I'm sharing my screen.
And Ms. Tuğçe Sezgin's speech title is Enhance Chitin Nanofiber Productivity from Marine Diatoms Through Strain Selection and Cultivation Process Optimization. And floor is yours. You can share your presentation directly. It's available right now.
I shouldn't share right now. Sorry. Okay. I think it's okay.
Yes, it's better. Thank you.
Hello everyone, I am Tuğçe from İzmir Institute of Technology. Today I'm going to present our work and it's about chitin nanofiber productivity from marine diatoms. First of all, I'm going to explain what are diatoms. They are subdivision of macroalgae and they have silica cell wall unlike other classes of macroalgae. And species belonging to Psychotella and Thalassosira genera biosynthesis and extrude chitin nanofibers, and they are only source of pure chitin in nature. So what is chitin? Chitin is an organic biopolymer N-acetyl-glucosamine units linked together, and there are many derivatives of chitin. But the most important one is chitosome. Actually, chitin is second most abundant biopolymer on Earth after cellulose. And chitin and its derivatives are biocompatible, biodegradable, and non-toxic. They are used several biomedical industries, such as biomedical, pharmaceutical, cosmetics, food and beverage industries, and they have a total market of $4 billion in last year. And today, the chitin demand is mainly supplied from shellfish, but it causes some problems. For example, the amount of chitin that can be extracted is low in shellfish, 20 to 30% chitin of biomass. And other important problems is the chitin bounded with proteins and other inorganics, and this causes impurity in the final products. And but diatoms belonging to Psychotella and Thalassosira genera are the only living creatures that produce high quality of chitin in the purest form, and they extract nanofibers out of the cell from portula. Maybe you can see in here, and they potentially simple extraction of chitin nanofibers, and chitin is not directly bonded with other organics and inorganics, and we completely extract the nanofiber from a cell. In our current research is about the comparison of chitin productivity of 9 strains belonging to Psychotella and Thalassosira genera And our aim is the select of the species with the highest chitin productivity actually. And we have two species and 9 strains with different habitats, which are marine and brackish. And we cultivated each strain in our bubble column photobioreactor under 2-stage cultivation processes. The aim is stage 1 is acclimation to PBR conditions for the flask culture, and the stage 2 is need to comparison of the chitin productivities under silicon replate and deplate conditions. And this is our bubble column photobioreactor, and these are our process parameters. We use artificial seawater medium, and our cultivation temperature is 20 centigrade degrees. And the main difference between stage 1 and 2 is actually the average incident light intensity. After stage 1, we increase this value 50 to 250 micromole per meter square second. For look at the cell number densities, in 9 strains, Psychotella cryptica 333 species strain has the highest cell number density. And when we look at this graph, we can easily understand that the circle one is the dissolved silicon concentration. When it is completely consumed, the cell number density reaches plateau. So what we understand in here, silicon availability is important for the cell productivity. But the second thing in here is the cell number density. When cell number density reaches plateau, the nitrogen consumption is still continue. So nitrogen availability required for chitin synthesis. For chitin productivity, final chitin concentration range between 30 to 300 milligram per liter, and again, Psychotella cryptica 333 is the highest final chitin concentration, and its peak chitin production rate is 15 milligram per liter day. So the yellow arrow shows the point of the silicon depletion, and we can easily see that when silicon is silicon depleted, chitin concentration and the chitin content in biomass is increased. It's important. For industrial applications, physicochemical polymer properties are important. So we did a diameter and length analysis of chitin nanofibers, and our results show that there are significant differences between all strains. For example, average fiber diameter around 50 to 90 nanometers. And according to previous study, we determined the best productive strain. And to understand the influence of process parameters and cultivation mode on chitin productivity and polymer properties, we cultivated Psychotella cryptica 333 strain under different process parameters on continuous cultivation systems. These process parameters are different light intensity, different temperature and salinity conditions. And we use continuous cultivation system and growth at constant turbidity to understand chitin formation, maximize chitin productivity, and control physicochemical polymer properties. So we determined the threshold value, and it was exceeded We have here fresh nutrient medium, and it's pumped into the reactor, and the same amount of suspension harvested in here. So this is our results, and it shows the cell division rate with turbidostat cultivation experiments. And maximum volumetric productivity was measured in highest light intensity, and the cultivation temperature is 25 centigrade degrees, and the salinity is 20 gram per liter. And we can see that the effect of total effect of actually on cell productivity was higher than other two parameters. So salinity is important for cultivation. In conclusion, all cycotol and thalassosyrate strains produce chitin nanofibers in beta form. Chitin productivity changed significantly between the strains, and Psychotella cryptica 333 strain had the highest peak production rate and final chitin concentration, and physicochemical polymer properties varied across the strains. Finally, I would like to thank the TÜBİTAK and the Integrated Research Centers of İzmir Institute of Technology, and also I would like to thank my supervisor, Dr. Altan Özkan. Thank you for listening.
Ms. Tuğçe Sezgin, thank you for your contribution. With your permission, I will ask the audience if there is any question.
Yes, okay.
Sure. If you want to add something more, or if you have any question, you can ask right now. Yes, please. We have one question.
Tuğçe, thank you so much for your presentation. This is Berat Aznarol from Boğaziçi University. I'm going to ask something very simple because I didn't understand. So chitin is mostly in the cell wall of the diatom. Is that correct? Or in your system, do you also have a chitin production in the cytoplasm? Can you clarify that issue a little bit? Did you hear me okay? No?
No, I couldn't hear, hocam, sorry.
Okay, is the chitin mostly in the cell wall of the diatoms, or is there any cytoplasmic accumulation as well?
Mostly in the cell, hocam.
In the cell walls?
Yeah, cell.
Okay. So is the normal growth promoting conditions of the diatoms contribute to chitin? Or no, not at all?
I'm sorry, hocam.
Aslan, maybe she can hear from you.
Can you please repeat?
It's okay, I will follow up with you later. Okay. I probably cannot make my voice now, right now.
Okay. Sorry, hocam.
That's okay, no worries.
Okay.
I'll call you later.
Okay, hocam.
Okay, then thank you again for your contribution to our conference. Thank you, we appreciate it.
You're welcome.
And dear guests, as you know, that's the end of the first day of our conference. Firstly, personally, as a member of independent project, and secondly, behalf of our team, I would like to thank you, all of you. And we were happy to welcome you here today. And I'd like to inform you about the gala dinner. Now we continue with the gala dinner. I suppose that you all have the social and scientific program on your table. In the fourth page, and also you can see from the screen, on the fourth page of the book, you will have the details about the gala dinner and location and other details. And it is important, please bring your conference name tag along with you. And again, thank you for being here today. You're appreciated. Thank you. And see you again tomorrow.